physics paper physics paper for class 10, prelim paper of a school, a reputed school. Section A, 40 marks compulsory. Your question 1 is MCQ. The position of the center of gravity of the body depends upon what? Distribution of the mass. So that is option C. What is the second one? The quality and timbre helps in distinguishing between two sound waves producing the same note, but the same note should be of uh, the same loudness and same pitch. Then the waveform will be helping us to differentiate. So what is the waveform? Is different sources, even if frequency and amplitude are the same, is correct, because two waves with same pitch and same loudness or intensity, if their waveform is different, you can. So true and true, and the correct explanation. Which option it is? Now sailor uses a pulley system. He finds that the rope has to be pulled much longer. Rope means the effort, so DE is greater than DL, correct? Now this means that velocity ratio, which is DE upon DL, write this reasoning, is going to be greater than 1. So your MA also is going to be greater than 1, which means it's a force multiplier, correct? Now force multiplier means MA is load upon effort greater than 1. So load is greater than effort. Okay, if you can do this mentally, well and good. If you can't, just show this. So load is going to be heavier than the pulley system can handle. No. Effort
is A option.
The effort is reduced. Correct. Okay, the effort is going to be reduced. Object is placed 30 centimeters. So 1 upon F is equal to 1 upon V minus 1 upon U. Can you see this person has got confused over here? V and U look the same. So you must make sure that you write it like so. How much is the focal length? 1 upon 10. 1 upon V you have to find out. And this is going to be U means minus 30. So your 1 upon V will be equal to 1 upon 10. This becomes plus positive quantity, goes there that side. So you will have 30 and 3 minus 1 means 2. So 2 upon 30 means 1 upon 15. V is equal to 15 is correct. The purpose of AC generator, the slip rings in it, is to provide continuous connection. That is why the EMF goes this way and then this way, alternating. Correct? But the connection remains continuous is the correct one. Here the power is 2 kilowatt and you are using half an hour every day. So the energy consumed is going to be 1 kilowatt hour per day. If it is in a month, that will be 30 days. So the total energy is going to be equal to 30 kilowatt hour. 6 rupees per kilowatt hour, 6 3s 18. So 180 is the correct option. 60 watt, 240 volt, 100 watt are connected in parallel. Which one will draw more current? The one which will draw more current will have less resistance. Agreeable to you? So you will have the first one giving you the formula P is equal to V square upon R. So R is equal to V square upon P. So if you look at the two resistors, you will have V square means 240 square upon 60 is to 240 square upon 100. This gets cancelled, 1 0 gets cancelled. So you have two 3s and two 5s. So 1 upon 3 is to 1 upon 5. So you have resistors, correct? Which one has got less resistance?
B, 100 watt.
Less resistance. And therefore, this is your thinking step. More current will be here.
Ma'am, we could do this by using P equal to VI also, right? And get the current.
P equal to VI and get the current through
In that ratio, we are getting 3:5. So the current drawn in the second resistance is more.
Yeah, you could do that also. And you can do it is mentally also, that if the PD is the same, the more power will draw more current, because it is 100 joules in 1 second. This is 60 joule in 1 second. Understanding? So this one is going to draw more current. Okay. Here, which one is going to be showing the softest, means least amplitude? Which is the least amplitude? A. Because loudness is directly proportional to amplitude square. On reversing the direction of the current in the wire, its
Ma'am, they're asking highest pitch also with softest sound.
Yes, ma'am.
Oh, sorry. Did I overlook it? Softest sound with highest pitch. Highest pitch is still A.
Ma'am, more frequency, right? So
1 minute, 1 minute.
B, right?
It is
highest pitch, B.
Oh dear me. But can you see this is looking more than this?
Yes.
But we'll have to take the ruler and measure it, huh?
Yes.
I think between this and this we'll have to decide. Now highest pitch only is this, but looks like this is slightly more. So if we have to take, actually we'll have to do this. Understood, no? Yes. So let us say this is 1 centimeter. Okay, this is also 1 centimeter. What about 1 centimeter?
1 centimeter. And this is 2.
No,
slightly less than 2.
So it is more than 1 centimeter.
Yeah.
Never mind what it is, but okay. So better to take the ruler and check it out. Okay. Here I was doing guesswork, but then it will be, this is 1 centimeter, 1 centimeter, 1 centimeter. So then it will be D option. Yes. Better to be absolutely clear about it. No? Better that way. On reversing the direction of the current, magnetic field will be reversed.
Yes, ma'am. Gets reversed. Okay.
Then the next one, diagram represent two blocks of copper, A and B. Copper means SHC is the same. Correct? Mass of A is 2 times. So this is 2x and this is x. This also has been given. Same amount of energy is supplied. If the same amount of energy is supplied, QA equal to QB, and Q is MC delta T of A is equal to MC delta T of B. Then SHC is the same, so C gets cancelled. This will be 2x into delta T A is equal to x into delta T of B. X and x got cancelled. What are they telling you? That the temperature of A rises to half.
When temperature B increases by 2x and of A
delta T of A upon delta T of B is 1 upon 2. Correct?
Ma'am, it would be B option because it's given specific heat capacity of A is same as that of B.
They are saying that delta T rises of A to half of delta T of B. Correct? Is correct?
Yes, ma'am. Yes, ma'am.
Now, which one explains? SHC of A is equal to, so this is not same as B. Yes, heat capacity of
Heat
A,
capacity.
heat capacity, heat capacity, heat capacity, heat capacity is going to be C dash A upon C dash B will be equal to M of A into C upon M of B into C. So M of A is 2x upon x. So C dash thermal capacity of A is twice C dash B. What are they saying? Of A is half, no,
D, ma'am.
and D.
Ma'am, but even B is... Why wouldn't it be B?
No, now the thing is that see here, SHC of A is the same as SHC of B. So if the SHC is the same, it is correct, right? Because both of them are
Yes,
copper.
copper.
But the controlling factor will not be copper, no?
Okay, ma'am.
The controlling factor is actually the mass. Is it not
Yes.
so?
Yes, ma'am.
Now, if I take only SHC, then I am not taking into account mass because SHC is for unit mass, right?
Yes.
Yes,
SHC, when we define, it is the heat required to raise the temperature of the unit mass. Is it not so?
Yes.
But we have masses different. Because of the masses being different, there is difference, right? Why is there difference in the delta T? Because their masses are different. Not because SHC is same,
Okay.
no.
Yes.
It is not because of this. So this was a good question because you'll tend to say, mere ko mila. And we won't even look at this, correct or no? You understood, no?
Yes.
Yes.
That is the reason you have to look at all the options, okay? The moment you see the correct one, don't just move to the next one because this is the trick part. Understood, no?
Yes.
Okay. Now, total internal reflection, the value of critical angle will be minimum. Now, critical angle will be, maximum. So, remember, mu is equal to 1 upon sine of critical angle. Now, we know diamond to air, diamond has got max mu, correct? For the diamond, we know that mu is maximum, therefore critical angle is going to be minimum. So you have to look for the maximum critical angle, means you have to look for mu minimum. All right. Now glass to air. What is glass to air? G mu A. I know that A mu G is equal to 1.5 means 3 upon 2, correct? So G mu A is 2 upon 3.
Yes.
Which will be less than 1, correct?
Yes.
Now glass to water. What is glass to water? It will be 4 upon 3, that is mu W upon mu G. Mu G is 3 upon 2. How much is that? 4 upon 3 into 2 upon 3, which is 8 upon 9. Now this is going to be 2/3 means 0.67, and this will be 9/8, no? 72. Okay, and water to air. Water to air is going to be equal to 1 upon air to water, correct? Understanding? This will be 1 upon A mu W. Understanding what I'm doing? Now, A mu W is 4 upon 3. So this becomes 3 upon 4. That is 0.75. Okay, so the least mu is this. So mu will be maximum for A. plenty of work they extracted for that 1 mark. है ना?
Yes, ma'am.
The ray of light incident, so this is angle I1 is 48, but it is at a minimum deviation, which means I1 equal to I2 equal to 48. If you don't remember this formula, remember A plus delta is equal to I1 plus I2. So 60 degrees is angle of prism given over here, plus delta min will be equal to I, and I means 2I means 2 into 48, which is 96. So 60 goes that side, delta min becomes 36 degrees. This is the question where heavy and stable nuclei, they have more neutrons than protons. If they are stable, then that means the protons which are sitting inside the nucleus with positive charge and number of neutrons which are uncharged are here in the nucleus. And if it is stable, when it is stable, remember the protons they have like charges, so they will have the repulsive force from each other. Understanding, like charges repel, correct?
Yes,
And the number of neutrons being more is going to stabilize the nucleus. Okay, the reason is that the protons will not move away and they are held together because of the nuclear force which is attractive in nature. This part is not in your syllabus, but since it is asked over here, so remember to counteract the repulsive force between the protons, we have number of neutrons increasing and it is stabilizing the nucleus. So this is the correct option. This is not really part of your syllabus, but I'm just explaining this to you. We come to radioactive isotope emits one alpha particle and two beta particles. Then the mass number, what is going to happen? Your A is going to become A minus 4 because of one alpha particle, and then it will remain unchanged. But the atomic number will be Z minus 2 because of one alpha particle, and then two beta particle means 2 will be added.
Plus 2.
So you will have Z will remain Z. So the new element or new atom is going to be like this. What has happened? The mass number has decreased by 4, decreased by 4, decreased by 4. But atomic number is unchanged. No. You're with me?
yes.
Okay. So B option is the correct one. The last one, 15th one, looks fission. Which one is fission? One
C.
heavy
C.
is splitting into, so it is C option. Write your marks on 15. Question number 2 is your fill in the blanks. Dash has maximum ionizing power will be alpha because it has heavy mass. Okay, so your A is alpha. Don't write the whole thing. B, decrease in pressure over ice will lower, increase in pressure lowers
its melting point.
So decrease in pressure will increase. Lenz's law is based on law of conservation of energy, correct?
Yes, ma'am.
Yes, ma'am.
Higher the current rating, the fuse wire will have to be thicker. Why thicker? Because it increases the
resistance will be less, so the
area of
loss of
cross
heat will
section.
become less.
Yeah, now remember, in your reasoning, don't start with resistance less. Start with area of cross section more, and then R is inversely proportional to area of cross section if this is coming as give reason. Okay, start with which one? That area of cross section is more, decreases the resistance and allows more current to pass by minimizing the loss of energy in the form of heat. Understood? That would be the actual give reason. Sound box for the instrument is constructed so that the air column has natural frequency
equal
to.
So that resonance occurs.
Yes, due to resonance, larger amplitude and louder sound. Class 3 lever load arm is. Now class 3 has effort in the middle. So this is your fulcrum, this is the effort, and this is the load. Remember, load is always vertically downwards and effort here will be in the opposite direction. So this is your effort arm. If you get a little confused, always show this way. So the load arm is it greater? Is load arm greater? Longer. All right, we come to match the columns. Ideal machine will have
MA
equal to VR. So A will be the second one and B practical machine.
MA less than VR.
This is literally they are throwing marks, no? Write your marks. Are you getting good marks for that?
Yes.
Okay, let us come to this one. Calculate the value of resistance which must be connected to this to provide effective resistance 6. So what you will say?
Parallel.
Because effective resistance, so what you will say?
Is less.
Equivalent resistance is less than, we'll write in symbols but in the exam write in words, okay? Less than 15 ohms. Therefore, let R be in parallel with 15 ohm. Okay, then 1 upon Rp is equal to 1 upon R plus 1 upon 15. So 1 upon 6 is equal to 1 upon R plus 1 upon 15. 1 upon R therefore will be 1 upon 6 minus 1 upon 15. You have 30 as the LCM, 6 5s minus 15 2s. So we are getting 3 upon 30, which is equal to 1 upon 10. Therefore, R is equal to 10 ohm. Then what you'll say?
Resistance of 10 ohm should be connected in parallel with the 15
rather than resistance of this thing, 10 ohm should be connected in parallel. Okay, what is an ohmic resistance? Learn it if you do not know it by heart yet. This was for 1 mark, this was for 1 mark. The central portion, question number 3, is wrapped up with black paper. What will the image be formed or no? Will the image be formed? Justify your answer. Will the image be formed if the ray is coming from distant object? What would happen? Are they meeting the rays?
Yes.
Okay, so even though, like supposing I'm talking about this and we'll say the second ray will go through this, but this part is black, but still I will get the image. Yes. Justify the answer. You have to show the diagram the way I showed you and say that as seen in the diagram, The two parallel rays on either side got refracted and converged at a point, so the image will be formed. Okay, and it will be real image. Don't say diminished blah blah whatever, because we are just taking the case of an object placed at infinity. The beaker containing water is placed in a vessel of boiling water. Will the water of the beaker also start boiling? Uh, give reason for the answer. For this, what will you say? Boiling water. So this is 100 degrees C, and we are taking water inside this. This is, let us say, at 10 degrees C. Okay, this has more heat given to this, correct? So you will have M1C delta T, it's boiling water, right? So what will we say? Vessel of boiling water. Boiling water means army is supplying the heat is equal to M2C delta T2. C got cancelled, and that means they are saying will this also reach 100 degrees? Getting me?
Yes, ma'am.
Yes.
Yes.
So how would we frame our answer for this?
Ma'am, no, because according to principle of calorimetry, heat lost by a body is equal to heat gained by a body.
That is what we have said. Okay, this is heat gained by 10 degrees C is equal to heat lost by 100 degrees C. Correct or no? But after that, how will you explain? Just that much? Masses also will play part, no, in that. What will be delta T for this? X minus 10. What will be delta T for this? 100 minus X. Correct? So if you consider equal masses, then X minus 10 will be equal to 100 minus X. So 2X is equal to 110. So X is...
We can also say that the vessel which is kept inside the water, inside the beaker, it will not start boiling because it will not get the additional heat of latent heat of vaporization.
Latent heat of vaporization, we are not yet coming to that. It is just at 100 degrees C.
Okay.
So can you see this? Can you see this? If the masses are... Okay, now they are saying will it also start boiling, which means this X should be equal to 100, correct? Understanding?
Yes, ma'am. Yes, ma'am.
Which means 100 minus 10 into its mass should be equal to here 100 minus 100 into mass. Understanding? I think this is a better reasoning. What do you say? Aren't you getting 0 here? 0 multiplied by M2. Did you understand this?
Yes, ma'am.
If this water also starts boiling, which means the final temperature, the temperature final should be 100 degrees C. Understanding?
Yes.
So
Ma'am,
if that is the case, then you will have 100 minus 10 is delta T for the water which is kept in the beaker will be equal to 100 minus 100 into M2.
Ma'am, then M1 will be 0, right?
What will be 0?
M1. How can the math be 0?
That's what. You cannot have the heat supplied heat. This is heat supplied by the boiling water, right?
Yes, ma'am.
MC delta T, CC got cancelled, right? So heat supplied by this vessel comes out to be 0, and that will give me M1 equal to 0 upon 90, which is equal to 0, which is not possible. Getting me? Understanding, right?
Yes.
So how will we word it? How will we word it? If water in beaker boils, then delta T for it will be equal to what? It will be 100 minus the initial temperature. Agreeable to you? Hello?
Yes, ma'am.
No, mistake. It is initial temperature is T1, right? Initial temperature is T1, it will become 100. Sorry, it was correct. 100 minus T1. Okay? Then the water in vessel is at 100 degrees C. Therefore, delta T for the vessel will be what? 100 minus 100, which is equal to 0. Okay? By law of or principle of calorimetry, you will have heat gained, because it's 2 marks, no? Heat gained by water in beaker will be equal to heat lost by water in vessel. Water in the vessel. So I will say M1C delta T1 is equal to M2C delta T2. C got cancelled because both of them being water content. So M1 into 100 minus T1 is equal to M2 into 0. So M1 will be equal to 0 upon 100 minus T1, which is equal to 0, cannot be possible. I think mathematically we could show it like this. Therefore, water in beaker will not. See the font size I changed for not. Start boiling. You're with me?
Yes, ma'am.
Okay, now as you can see, I'm seeing this paper for the first time. I did not look at it earlier, and I'm not teaching you after looking at it earlier. So on the spot, how to think, you are getting the training for that. All right? Uniform meter scale in equilibrium supported at 60. So this is how mass M is suspended from 90, and give reason where the weight of the scale is greater. This was an ICSE question earlier. This is going to be your weight of the ruler. This will be
W.
your W1. Let us call this as W2. Okay, so now don't draw the diagram, just say W1 equal to question mark. Okay, and L1 is how much? Isn't it 10 centimeter?
L1 is 10 centimeter.
Just write that much. We can't write everything.
W2
Is equal to mgf, and L2 is how much? 30 centimeter.
30 centimeter.
So by the principle of moment, we will write put dot dot dot. Sum of anti-clockwise is this.
W1 into L1
is equal to W2 L2.
To L2.
So that will be W1 into 10
is equal to
M into 30. Okay, so your W1 is equal to 3 times M. They are saying, is it greater than? Yes. So what you will say? Therefore, weight of scale is greater. Underline the keywords. Greater than M. Understood? Underline this like this. Don't sit with rulers, and if this is your line and you write your greater like this, don't make the line on this line only. It should be a little below so that it's visible. Okay, understood? Sometimes when you draw the underline here along the line, it will not be visible. Is this visible to you when I draw the line again to underline? No, no. So whatever you write, the underlining should be done somewhere here. Understanding?
Yes, ma'am.
Okay. So make sure that it is visible. It catches the examiner's eye. It is important that the examiner immediately looks at the work and gives you your mark. A particle is placed at point A of frictionless track. This is A, right? XYZ. We don't speak American English, no? It's not a Z, okay? It's Z. XYZ, and it is slightly pushed towards the right. Okay? Find the speed with which it reaches point. Where is Y?
Ma'am, it's in the U part.
Oh, here, this is Y.
Yes.
Yeah. Okay. Now for this, how much is this over here? This is point, oops. Is it 0.5?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Is it 0.5?
Yeah.
So this is going to be again 0.5. Okay, meters. Correct? This is 0.5 and this also. So the height above the ground is this. So what are you going to say? The initial potential energy
is equal to final.
Ma'am, at that point, the potential energy and kinetic energy will be exactly half, so we can equate it.
They are going to be the same.
Mass is not given.
Mass is not given is correct.
Yeah. So
now you have to find the speed with which. So you will say that initial potential energy will be equal to mgh, correct?
Yes.
Let us call that as mgh1. Okay, and that is going to be equal to the total energy at y, correct? So mgh1 is equal to potential energy plus kinetic energy at y. What will you write over here? By law of conservation of energy, correct? So mgh1 is equal to mgh1 upon 2, correct? Yes?
Yes, ma'am. Yes, ma'am.
Plus half mv square. Okay, you're with me so far.
Yes, ma'am.
Yes, ma'am.
So you will have this comes here.
So it will be
So
half.
mg into h1 upon 2 means 1 upon 2 is equal to half mv square. Okay, and then m and m gets cancelled, and then you substitute and get the answer. How much are you getting? 10
Root 10.
into half is equal to half into v square. So v square
root
is
10.
equal to 10 and v is equal to root of 10. Have you made any mistake?
Ma'am, the kinetic energy should be 1 by 4 mv square, because it is at half, ma'am, exactly.
No. Whatever is half mv square is the kinetic energy formula, right?
Yes, ma'am.
So whatever velocity at this, basically you could also say that the kinetic energy over here is going to be the total energy minus total potential energy minus potential energy over here, correct or no?
Yes, ma'am.
Yes, ma'am.
So it is
Yes, ma'am.
half mgh only is correct. Half
Yes.
mgh is here. Velocity is not changing. How can you make it as 1/4? Height has got nothing to do with kinetic energy. Kinetic energy controlling factor is the mass and the velocity square, right? But that would be equal to half of the original potential energy.
Ma'am,
Huh.
can we use the formula V square equal to 2GH for this?
Now we have used that only. Now if it goes.
We
over
have
there.
used that only.
Yeah, it's just
But if
derived.
it's a 2 mark, no? So we write all this by law of conservation of energy.
Okay, ma'am.
Alright? Then the statements are better. Use that
Yes,
for
ma'am.
MCQs, but otherwise if it's like a long answer type or short answer type like that, better to show the working.
Yes, ma'am.
And if they provide with the logbooks, then this will be 3 point something. Correct or no? Because 3 square is 9, 4 square is 16. So it is 3 point something. Understanding?
Yes, ma'am.
Your answer is in square root. In physics, you have to give your answer in decimal, correct?
Yes, ma'am.
So better to ask for logbook. If they do not have the logbook, say, ma'am, we need the logbook. Okay, tell the examiner.
Yes, ma'am.
Your answer should be in decimal, otherwise 1 mark will go. This is the question you have to learn by heart. Differences between this you have to learn by heart. Then let us come to the dolphin. Is swimming below the surface of the sea. Looks at the bird. Now remember, I had told you the frog or the fish looks at the fly and the fly looks at the frog. In the water, it is denser medium, so the frog will be looking closer. But if the frog looks at the fly will be seen further away, because apparent depth in the denser medium, apparent depth is less than real depth, correct? And the apparent depth in the rarer medium is greater than the real depth. Keeping this in mind, you will answer this. What would be our A answer? Bird appears to be higher up, correct?
Yes.
Yes.
So it will be higher up. And then they say draw the neat diagram. So when you draw the neat diagram, you will have to show this first, and you will show the reference line for the bird, like so. show the bird somewhere closer, and you will take more slanting ray. Don't take a ray like this. This is less slanting. You will not be able to turn it towards the normal. Okay, take a nice slanting ray. Understood what I'm telling you?
Yes.
Then you will draw the normal and then allow it to get refracted. It will turn towards the normal, produce this backward. I'm sure you have rulers with you and you're not doing freehand. Don't be lazy over there. And you are going to show this as a dashed line. The ray is coming from the bird. This is the dolphin. Okay, so dolphin's eye, if you can. So this is going to be the image of what? The bird. Call this point as A, call this point as O, call this point as I, and show this as 90 degrees. You must show this reference line. If your eye, you will show either this side or this side, you will get a 0. Understood what I'm saying? You have to have this reference line. All right? And what will you write for the labeling?
Ma'am, the rays will also be like OA will also be the ray, right? One way.
No, now the OA is the reference line. We are not, if we are taking the bird this way, then this way you can show.
Yeah.
Okay, so it will go along the same straight line.
Yes.
Yeah, you could show that also. Yes. Now what will you write for the labels? Tell me. What is OA? It is the
The real height.
real height. And what is I?
Is the
From a reference point is A, no? So IA will be equal to the apparent height. Understanding? And I would also say IA greater than OA.
OA.
All right, so we have done this and we got 3 marks for that. Okay, 2 marks for the diagram. So we finished with approximately 40, 45, 50 minutes we've taken, I think. How much is this number? 48, no?
Yes.
With the explanation. So that is good speed. Let us come to the second section. There are 5 questions and we have to attempt 4. For ICSE, you probably will have to attempt out of 6. When you get the paper in hand, what should you be doing for section B? Section 2, always read the second section first. Decide upon the choice questions, which ones you will attempt, which ones will have least confusion for you. Okay?
Yes, ma'am. Yes, ma'am.
Object is of height 6 centimeter, at a distance 30 centimeter, in front of the convex lens, focal length given. What is given? The height of object is given as 6, but it will be plus 6 centimeter. The object distance U in front means minus 30 centimeter. If you are confused about sign convention, watch my videos on sign convention, okay?
Yes, ma'am.
Focal length is going to be, it's a convex lens.
So positive.
So it will be plus 10 centimeter, and what you'll say, since convex lens. All right, they are saying position of the object. Find the position. 1 minute. Object or this thing is placed here. They are saying Position of the object.
Need to find small v.
Ma'am, that would be the distance of the object. They have made an error.
I mean, it is given over there. So if they write like that,
Yeah, it
so
would be of
fine.
image maybe.
Can we?
In front of the lens beyond 2x.
Yeah.
The position. Okay, so I think we'll have to. No,
This
it is
line.
30, so it is beyond 2f. So position of the object. So object is
In front of the lens beyond.
is in front. It's making us think the paper in front of the lens, although it is, we'll say that what a stupid question, but maybe we have to make sure that our 1 mark is not lost. In front of the lens at a distance beyond 2f, correct?
Yes.
2f1 if I'm not mistaken, because 2f1 will be 20 and here it is. Okay. B,
Yes.
the
Yes.
size of the image. For the
First,
size of the image, I'll have to find the
Position of
Object.
I'll have to find the
Image
position
distance.
of the image, correct?
Yes, ma'am.
So I will use 1 upon f equal to, everybody knows this formula by heart.
Yes.
So 1 upon
1 upon
10.
10 is equal to 1 upon v minus
Did you write this
1
properly?
upon
Yes.
minus 30.
This you wrote properly?
Yes.
Dirtily. I said properly, you wrote dirtily, Babu. Why would you do that? Why would you not get into the habit of writing things neatly? Hmm? You are not interested in your marks, looks like. You are in love with your own handwriting only. Ma'am, say what you will, I don't want to improve my handwriting. That's the way I am, ma'am. What to do? Sounds so silly, no? How much is it?
15
1 upon 15, I'm skipping the steps.
Yes.
So V is equal to how much? 15 centimeter. Okay, now they are saying the size of the image. So you will have magnification equal to I upon O, which is equal to V upon U. Now the size of the image is I. The size of the object is 6 centimeter. V is equal to 15 centimeter. U is equal to minus 30 centimeter. So I is equal to 1 upon 2 into 6 with a minus sign. Correct?
Minus centimeters.
So this is equal to minus 3 centimeter. So therefore size of image equal to 3 centimeter, and it is inverted because of that minus sign.
Yes.
Then characteristics of the image, it is real, it is diminished, real inverted will go together, okay? Real, inverted, and then we'll talk about it is halved, no? Isn't it halved? So it is
Diminished.
And between 2 and 1
and between it is 15, means it is between f1 and 2f1.
Ma'am, will it not be F2 and 2F2 because it's convex lens?
ओए mistake किया मैंने. It is the convex lens. F2 and 2f2. I was thinking of something else in my mind and I got distracted and I made a stupid mistake. So stay focused. Learn from my mistake. Okay?
Yes, ma'am.
Airport security, passengers, luggage scanned. Name the part of electromagnetic spectrum they are using.
X-rays.
X-rays.
One property of these that makes them
Do not penetrate through the but penetrate through the-
suitable. Yeah, they cannot penetrate through metallic objects, correct? So it can be detected. Why are these waves preferred over other visible light for security checking? Other visible light. So what you will say, visible light,
It is blocked by suitcase cover.
visible light is blocked by, or it does not penetrate the opaque objects, correct? Only for from transparent, correct or no?
Yes, ma'am.
Yeah, but X-rays can penetrate through the opaque, but they are stopped by the
Metallic objects.
metallic objects, correct?
Yes, yes, ma'am.
So you can write that. They see, some of these questions are common sense questions. Can you see that?
Yes,
But now you have to make it into physics and we have to write. Okay. Monochromatic point source O as seen through rectangular block. Path of two rays in and outside the block are shown in the figure. Does the source appear? This was also an earlier ICSE question actually. O appear nearer or further away? So this is going to be nearer, correct or no?
Yes, ma'am.
Yeah, because of the emergent light, it will come closer. Where is the shift? It was originally here, but this point has moved this way. Correct?
Yes,
Understanding. So it will be nearer to AB. Okay? It will come nearer to AB. Then how does the shift depend upon thickness? It increases with increase in thickness since directly proportional. You can write that on your own.
Yes, ma'am.
Justify your answer by redrawing the diagram given in the same, showing the increased thickness of glass from C dash to D dash. This part some of you may not understand, so I'll just tell you what you have to do. Quickly show one rectangular glass block and increase the, did you understand what has happened?
Yes.
Okay, so you show A, B, and this is C, D, and this is your C dash and D dash. Okay, so this is the original thickness, correct? And this is the increased thickness. Done that?
Yes, ma'am.
Now you are going to take the incident ray and show it going through this surface CD, okay? Make sure that it is going through this surface CD. Don't show it like this going. Don't show it this way. Understanding? Understood?
Yes,
Yeah, I
ma'am.
said this we
Yes,
don't
ma'am.
want. Understood what I'm saying? It should cut C dash D dash. You're with me?
Yes, ma'am.
Next is you'll have to show a normal here. All of you know how to make that 90 degrees.
Yes, ma'am.
And then we have to show the original path, means this part has to be dashed line. Your dashed line should not be this way, this way, this way. The dashed line should be like this. Understanding? Hello.
Yes, ma'am.
If possible, invest in a pencil which is reasonably dark. Don't use light pencils for your diagrams. Don't use HB. Do you get something like 2B or more than just, there is, do you know lighter lead and little darker lead you get, na? Two types of leads.
Yes, ma'am.
Yeah, so slightly darker lead you have to use, and don't press the pencil point too much. just light and firm stroke, and take the eraser and just with the corner of the eraser, if you do that, you will get this very very quickly rather than doing this way. Did you understand the tricks I'm telling you for the dashed
Yes,
line?
ma'am.
Yes, ma'am.
Understanding?
Yes, ma'am.
Okay, now that you understood how to draw the dashed line for something like this diagram, what will you do? Tell me. You will show now this ray is going to go from rarer to denser, so it goes towards the normal, correct? But remember that we are having the CD stretch to C dash D dash. Did you understand what has happened?
Yes, ma'am.
So it is going to emerge from here parallel to the original path, and this would be the one which was the earlier one. You understood? If it was emerging from CD, it would have gone this way. Understanding?
Yes, ma'am.
But now because C dash D dash is not here, it will go this way. Understanding? Now from here to here, take exactly perpendicular distance. Don't show crooked line like this. Make sure that it is perpendicular here. Call this as lateral displacement 1. Okay, then take this from here to here. You will have to make sure that this diagram is slightly big. Okay, this one is going to be, tell me, lateral displacement 2. Understanding?
Yes, ma'am. Yes, ma'am.
Now what are you going to say? That AC dash is greater than AC. Why? Because increased thickness. And from the diagram, what do you say? Lateral displacement 2 is greater than lateral displacement 1. In the exam, spell this out. Okay, therefore lateral displacement increases with increase in thickness. Did you understand how we justified? Did you see how I'm double underlining this?
Excuse me, ma'am.
Huh.
Ma'am, I think they were asking for shift.
Shift is lateral displacement, no? Okay, fine. So therefore shift increases with increase in thickness. Okay, lateral displacement is the shift. The perpendicular shift is the lateral displacement, right?
Yes, ma'am.
Okay, so you understood how this was to be done. All of you are
Yes,
clear
ma'am.
about
Yes,
that.
ma'am.
Yes.
Okay, we come to number 5.
Ma'am, we
the
left
D
the
part
D,
is left.
D part.
Okay, now we come to the D part. For the same rectangular glass block, which color from visible spectrum produces maximum shift?
Violet.
Violet.
So here, now you say violet directly, but some of you may get a little confused, and I'm sure they are a little confused even now. So double check this. This is going to be as lambda increases, what will happen? Mu decreases, and mu decreases, the lateral displacement directly proportional, correct? That means for red it is minimum, and for
violet
this it will
maximum.
be maximum. So for the same rectangular block, the maximum shift will be, what you will write over there, D, violet, and what you will say, since lambda violet is less than lambda red, therefore lateral displacement for violet is going to be greater than lateral displacement for red, correct? And what you'll say, since lateral displacement inversely
Exactly.
proportional to the wavelength. Okay, this you will write in words. Understanding.
Yes, ma'am.
Define SHC, learning work, SI unit of SSC, joule per kilogram per Kelvin. I know you'll be tempted to write degree C, but write Kelvin. Let us come to, oh my goodness, what kind of, how do I go with this now? Oops. Certain amount of heat Q will warm 1 gram of X by 3 degrees C and 1 gram of material Y by 4 degrees C. Which metal has greater capacity? Greater heat capacity. Now heat capacity is M into C. Okay, which means if I'm taking 1 gram of both, it will depend upon the SHC. Greater heat capacity will be greater specific heat capacity. Which one has greater heat capacity? X, since it shows less delta T, change in temperature. Or you can say X, since it will have smaller rise in temperature.
Yes, ma'am.
Now, some of you may get a little confused for that. So you are going to say that Q for X is equal to Q for Y, and write over there since same heat. All right. So we have MC delta T for X equal to MC delta T for Y. What you will say, since Q, that is heat, is MC delta T. Okay. This will give you 1 gram mass getting cancelled.
Yes, ma'am.
So C for X multiplied by delta T for X is 3 is equal to C for Y into delta T for Y is 4. So Cx upon Cy is equal to 4 upon 3. Correct?
Yes, ma'am.
Therefore, I will have Cx is greater than Cy. Understanding?
Yes, ma'am. Yes, ma'am.
Therefore, the heat capacity
of X.
which is equal to M into C, which is equal to 1 gram into SHC. Okay. Uh, Therefore, heat capacity of X will be greater than heat capacity of Y. Okay.
Smart.
Yes, ma'am.
You could word this differently also. The essence will be the same. It is for 1 mark only.
Yes, ma'am.
Okay. Even if you say that since X shows lesser rise in temperature, its SHC is more, therefore heat capacity more. You can even write like that. Now, if you say this also, you will get marks. If you write this also mathematically, you can get mark. And sometimes you may get a little confused for this part under exam pressure. So remember, your water has 4200 joule per kg per Kelvin. This is high SHC, correct or no?
Yes, ma'am.
And that results in lesser rise in temperature.
Yes, ma'am.
If you keep this in mind, it will help you. Understanding.
Yes, ma'am.
Now how do I do this?
Ma'am, you can rotate the
Rotate कहाँ पर है?
right. The,
Is this the one?
no, ma'am.
No, ma'am. Just go slightly.
This one, no?
Yeah, this one.
Yes. So I need to just increase a little bit of, yeah. This is good?
Yes,
Yeah. All right. So the time temperature graph is for the substance being cooled. So tell me, what is this? This is vapor, this is liquid, and this is solid, correct?
Yes, ma'am.
Yes, ma'am.
Okay, so let us understand that first. From higher to lower. What is the boiling point? Boiling
200
point
degrees.
will be here.
200.
This is liquid, so
Yeah.
it is 200 degrees C. What happens in region DE?
Solidification, freezing.
Freezing.
It is going to be, yeah, freezing. 1 minute. Let us see what they have given. We don't want to lose. Didn't they? Sometimes they'll put mass over here, no? So I was just checking whether mass was given. Okay, so mass is not given, so then we are safe. So what you'll say?
How that would make a difference?
No, then I will say it will be freezing. What happens? So freezing. So I would say if that was mass given, let us say it was 5 grams given. Understanding?
Yes, ma'am.
So
Yes.
then I will say that in region DE, 5 grams of liquid freezes into 5 grams of solid at 150 degrees C without any rising temperature.
Yes.
Okay, now if I say only freezing, I would still want to make sure that my mark is secure. What will I say? That
Certain mass of liquid.
no, given mass, not certain mass,
Okay,
given
given mass
given
of
mass.
given
Okay.
mass of the
So
liquid
given
will change
mass of liquid,
At 150 degrees Celsius.
last, that should be last. Okay, given mass of liquid uh, freezes, freezes,
Mass of
no, sorry, given mass of liquid
Freezes.
at, sorry, at 150 degrees. Okay, we should write that. Freezes into,
same mass of solid.
Now we can write that in last also as constant temperature, which is 150
Yeah.
degrees.
equal mass of solid at 150 degrees C, comma, without any,
Change in
Rise in
temperature.
temperature.
pardon me, without any,
Change in temperature.
I would write fall in temperature because I'm cooling it, right? So freezes. Did you understand this?
Yes, ma'am.
Okay. Understanding.
Yes, ma'am.
Did you see that?
Yes.
Keywords. Did you see the keywords? So this will secure your 1 mark. Understanding. Okay. What is the, why is the region DE shorter than BC? So this is freezing and this is condensation, right?
Condensation,
Huh. So what you will say during
freezing,
DE,
water change.
during DE, that is freezing, the intermolecular spaces are reduced. Releasing less heat energy than during BC, where, comma, where intermolecular bonds are formed which releases more energy. Okay, now releases less heat energy. Here I would want you to write specific latent heat of fusion, understanding, or latent heat of fusion. And here more energy is what? The specific latent heat of vaporization. You can just spell it out as latent heat of vaporization.
And after BC, do we need to write that is condensation?
During BC, into bracket you can put, yeah, condensation. It is better to write that. Very good. Good point, Prabhu.
Okay.
All right.
Yes, ma'am.
They can even ask you what is the melting point. What is the melting point?
150 degrees Celsius.
Correct.
150 degrees C.
Why are you asking me a question? You should know this is a meeting.
Yes.
So don't ask a question. You should state the answer.
Yes.
Question means you are doubtful.
Yes.
Okay, then you say, is it that? But it is that, right?
Yes, ma'am.
So don't say, ma'am, is it that? No.
Yes, ma'am.
Okay, if when you ask me a question, then I get worried. How you don't know something simple like this?
Yes, ma'am.
You know? So you should state under question. Okay, now let us look at this. By the way, for this question, what else they could have asked? They could have given you that it is 5 grams of the substance. And can you see over the minute time in seconds is given? They could have given you that the heat is extracted at a rate of, let us say it was kept in the fridge for some time and the power was 10 watt. Then from here to here, how much heat you could have calculated, right? It would be 10 into 5 means 50 joules it would have been.
Yes.
Yes, ma'am.
But if they ask you now over here, what question they can ask you? Specific heat capacity of the vapor. If they ask you over here specific latent heat of vaporization, then you will check this. How much is this? 15 seconds, correct?
Yes, ma'am.
So
Yes,
how
ma'am.
much would be the heat over here? P into T means 150 joules. Understanding?
Yes, ma'am.
If they ask you over here, what question they will ask you for CD? This is now
Specific heat
solid.
capacity.
So SHC of solid.
Liquid.
Sorry, liquid. Yeah, liquid. SHC of liquid. Then in that case, you will take your heat as, this is 5 seconds.
Yes, ma'am.
So the heat which is liberated here is P into T means 10 into 5, that is 50 joules. What they will ask you over here? Specific latent heat of fusion. Then in that case, you will take here 10 seconds and then your heat would be P into T will be 100 joules is equal to mLF. M is already given as 5. Understanding?
Yes, ma'am.
And if they ask you for EF, they will ask you SHC for the solid. In that case, you will take again 5 seconds. Understood how this graph can be used for any number of questions?
Yes, ma'am.
Did you see that? I have just given you 5 questions that can be asked on this graph. Understanding?
Yes, ma'am.
Yes, ma'am.
Okay, so let us come to the next one. It's going to give you a good review of the syllabus of yours. 1 kg at 0 degrees C of ice, continuously heated and the power has been given. Assuming all heat is transmitted to ice means there is no loss of heat energy. calculate the time interval in seconds for the ice to completely melt, water to heat from this, and these are the facts which are given. First thing what you will have to do, draw schematic diagram. Ice it at 0 degrees C, it is going to become water at 0 degrees C is going to become, that's it? That's it.
Water to 100 degrees Celsius.
Where is at 100? Oh yeah, water at 100, yes. Water at 100 degrees C, correct?
Yes, sir.
Now, this will be your Q1, this will be your Q2, and your Q1 is going to be MLF,
MLF.
Q2 is going to be equal to MC delta T. They are saying the time interval. For the A part, you will say that the energy supplied, okay? So energy supplied, obviously by the heater, is going to be equal to heat gained by ice. Okay, and by law of conservation of energy also you can say. Energy supplied will be P into T, and here it will be MLF, correct?
Yes, sir.
They are saying that it is 1 kilowatt means 1000 watts into time, let us call that as T1, and the mass of ice is 1000 into LF is how much? 336,000 joules per gram.
Then it will be 1000 1 kg. Right?
What did I write? I wrote,
Ma'am, then it will be 336 joule per.
no, sorry,
gram.
1 kg. I should have written over here 1 kg.
Yes.
1 kg. So your 1, 2 zeros have got cancelled. The third zero also got cancelled. So T1 is equal to 336 seconds. Did they say time interval in seconds? Fine. So this is your answer A. Okay, we come to answer B. Water heated means Q2. Okay, I'm avoiding these now. The Q2 is going to be equal to MC delta T, correct? So this will be power into T2 is equal to 1 into SHC is 4200 into delta T is from 0 to 100. So T2 will be equal to 4200 into 100 upon power is 1000. So 3 zeros got cancelled and you had 420 seconds. Then we will say the time for this. All right, I think reasonably simple question this was.
Yes, sir.
Same note at the same loudness on a guitar and harmonium, and a listener can identify very easily. So question 6.1, what you will say? Give reason. What will be?
This is so as.
This is so as the notes are from different instruments
Have different quality.
hence have different
Waveforms.
quality or timbre. Make sure that you are supplying these quality or timbre. That is
Different subsidiary.
different waveforms different waveforms due to number of uh, due to due to due to due to different
Number of subsidiary units.
yes number of
Subsidiary nodes.
subsidiary waves or nodes associated with the
Principal node.
associated with, so let us write this over here, note, with the principal node. Okay, draw the neat label diagram for the same.
I think they will be waveforms.
We'll have to draw two different waveforms with the same frequency and same amplitude.
Now neat label diagram for the same. Now what am I pausing for is I don't know exactly what is guitar and harmonium looking like. So I would say that two different waveforms with same loudness and same note at same loudness बोला है, same pitch नहीं बोला है, and same pitch if you say, then your diagram should look like this. Where shall I draw? There is more space here, so I'll just draw like this. You will show this as the reference line, show one graph here and the other one here. Okay, and write over there waveform 1 and waveform 2. Because why am I safeguarding my interest? Because I don't know the guitar and harmonium what kind of waveform it will have. Okay, then I'm going to show equidistant lines here and here, equidistant lines here and here, but these are dashed lines. Okay, I have to make sure that it is, if it is your ruled paper, no, just take the help of the lines which are there on your sheet and show this. Understanding? Write this as 0, write this as 0, write this as A, write this as minus A, write this as A, and write this as minus A. Understood?
Yes, ma'am.
Make sure that the axes are shown with the arrow. We don't want any mistake. Now remember that we are going to have the reference line. So I'm going to show just two waves. So I'm keeping this as also dashed line. For the two waves, I will show this way. And this also will be my dashed. Did you understand where you have to take care? Be careful of these things. These are going to be the dashed lines because they are the reference lines. Do not show them as bold. And then I will show the graph from here. The first one I will show with a normal thing like this. Don't take too much trouble over this. If we show this one as the pure note, then I can have the second one like this and go this way. Understood? Can you see what I'm doing? No, mistake. Oops, what did I do? Here, there is a mistake here. This way, then it will come here, so this way. Then it will go from here this way. Then it will come here this way. Did you understand what I've done?
Yes, ma'am.
Make
Ma'am,
sure.
but if we are mentioning subsidiary notes, then we'll have to show like
That's okay. They are saying draw a neat label diagram for showing the two different waveforms they are saying. I do
Okay.
not know that. If you want, you can make a little zigzag here and
Yes.
again a same kind of zigzag here. Okay, and then make it round here and round here. Then here, do you want to make zigzag like this? And here also identical zigzag you can make.
Yes.
But even if you show different waveforms, that's okay. That is why I didn't say over here guitar and harmonium. Okay?
Yes, ma'am.
By the way, what we shown this earlier, only this, that is your pure note of one frequency it will be. Okay? You could show a little zigzag here, but in identical places. Okay?
Yes, ma'am.
Yeah? So we understood. Huh. Now let us come to Ore Bapre, ये क्या हो रहा है?
Rotate once.
Okay. Pendulum has frequency 5 vibration per second. This is from the textbook, right? It's the same one. Everybody knows how to do this. For 8 vibrations, you have to find the time. So you have vibrations and you have time. If 5 vibration is 1 second, then 8 vibrations will be how much? 8 upon 5 seconds, correct? So our time is how much? 8 upon 5.
5 seconds.
I know it is 1.6, but you'll write it like this. Yeah, so this is the time for the echo. The velocity of sound is there. Find the distance. You will have V equal to total distance means D plus D.
2D.
That means 2D upon T. You can handle this.
D is equal to VT upon 2.
Correct, correct. Will the sound be audible if the string is set into vibration on the surface of the moon? Moon has no
atmosphere, so no medium of translation.
No material medium. No atmosphere is not physics. No material medium. Hence, sound cannot be propagated through vibrations. Understanding?
Yes, ma'am.
Yes, ma'am.
Okay, hence not audible. Can we handle that?
Yes, ma'am.
Tuning fork held near the open end, partly filled with water, level gradually is lowered. Now, if there is the level of water gradually lowered, means initial is L1 and now it is L2. What is happening? Your L2 is greater than L1, correct? How is frequency related with the length? Inversely proportional. So my F2 is going to be less than F1. Agreed? This is my thinking step. It is found that the sound becomes loudest when the length of the air column is 18, which means the two frequencies will equal at 18 centimeter. And then again it is 54 because can you see it is a multiple. So 1:3, which means in the closed air column closed at one end, the different modes of frequencies are 1:3:5. Can you see it is 18:54? So 18:54:90, correct? What is the name of the phenomenon taking place when it is loudest? All you have to write is resonance, correct? Then B, this is the thinking step. Then why are two different lengths giving the loud sound? So what you'll say, for the air column closed at one end, the different modes of frequencies are in the ratio 1:3:5. I'm just putting dot 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 there. Name the phenomenon when the sound is produced but not the loudest. Not the loudest means forced vibration.
Force vibration.
Correct? Since the two frequencies will not be equal. Avoid using the word matching. Oh my goodness, this child is, I don't know.
Ma'am, towards the right. Yeah, this one.
Thank you. You are provided with P1, P2, P3 connected so that P1 glows brightest. They are connected to the same voltage. The type of connection exists between the bulb will be parallel, correct or no?
Yes, ma'am, because it's in.
Yeah. Now they are saying that the power is the least, correct? That means,
Ma'am, that's not specified as power. That's just the.
what is P1?
It's just the bulbs provided to you are P1, P2, and P3 are connected in a
certain way so that P1 glows the brightest and P is not the power. They are just the names of the bulbs. It glows the brightest. Glows the brightest means the current will be maximum, which means this is the ratio of the resistors, correct? Do you agree with that?
Yes, ma'am.
Yes, ma'am.
They are connected. What type of connection is the parallel? Compare the voltage across the bulb. They are going to be the same, so equal. Compare the resistances. Can you see that?
Yes, ma'am. Resistance will be greatest for R1, right?
Yeah. So P1. So what you will write over there? P1 is the brightest, therefore has maximum I and minimum resistance, correct?
Yes, ma'am.
Hello?
Yes, ma'am. Yes, ma'am.
Okay. So therefore minimum R. So your R1 will be less than R2 less than R3.
R3.
Okay.
Yes, ma'am.
What do you mean by earthing learning? How is it done? Draw neat label diagram. That charcoal thing in the tube, that wire and
Yes, ma'am.
moisture surrounded by, okay, all that you will have to show 3 marks ke liye. Normally they don't ask that, but they have asked here. Diagram has EMF 9 volt and internal resistance 0.6 and 3 resistors A, B and C. Calculate the total resistance. Total resistance for that, what you will say? That B and C are in parallel, correct? So therefore 1 upon Rp is equal to 1 upon B plus 1 upon C, which is equal to 1 upon 4 plus 1 upon, is it 6?
Yes,
What is
ma'am.
it? Is it 6?
Yes, ma'am.
Yes, ma'am.
Okay. So I would like to write it as 10 upon 24 rather than taking LCM 12. So Rp will be equal to 2.4. Can you see that? This 10 will go in the denominator. It will help me in quickly getting my Rp. All right, then what you'll say, A and RP are in series. Therefore, external resistance will be equal to A plus RP. That is 2 plus 2.4. How much is that? 4.4 ohms. Correct? Therefore, total resistance is going to be equal to 4.4 plus small r, which is 4.4 plus 0.6, which is 5 ohm. Okay, so this is your answer A. For B part, the current I is equal to V upon R means E upon R plus R. EMF is 9 volt. Total resistance is 5 ohm. So 9 volt upon 5 ohm. 5 ones and 0.8. So 1.8 ampere. This is your answer B.
Ma'am,
Huh.
ma'am, they have asked the current through B and C.
This is current through the circuit, no Babu?
Sorry, ma'am.
I in circuit. Yeah. See, bacha, your speed of thinking is fast. So sometimes you may skip this step, no? Will you please be careful?
Yes, ma'am.
Yeah. Because your speed of thinking is fast, you'll have to be careful. Now, current through B and C, there are two ways of doing things, but the best way to do will be for finding the PD across parallel circuit. Will be equal to Vp and V is equal to IR, so IRP. I is how much? I'm writing it as 9 upon 5. Not interested in decimals just now. RP is how much? 2.4. I'm writing 24 upon 10. Okay, and I'm leaving it like that. I'm not interested in cancellations. I'll just write V over here. Understood?
Yes.
Then I will say current in B, IB, will
is
be equal to VP upon B.
RP.
है ना? How RP?
On resistance side.
No, this is B only, no? B is the resistor, right?
Yes.
So no need to write RB. I heard RP, P for Paschim.
Ma'am,
Okay.
we have to find in the current through B and C together, or we have to find separate for
Current
B
through
and
B
C.
and C. B and then
it can
C.
It can be like
No, it's not together. It's not together. Don't confuse yourself with that. 9 upon 5 into 24 upon 10, and you are dividing by B is 4. So 4 ones and 4 sixes. Correct? So I still do not want to cancel out here. I will write it as 36 upon 5 into 10. Okay, and
That will be 54 upon 5. 500.
54.
9, 6.
Yeah. Sorry. Yeah, in between my link when somebody spoke, no? 9 6 is 54. Sorry. Okay, so that will come out to be 5 divides this will be 10.8 upon 10. Did you understand what I've done? So it
Yes.
will be 1.08 ampere. Okay, and the current through C will be equal to Vp upon C, which will be equal to
IC is equal to
9 upon 5 into
24
24 upon 10 into 1 upon 6. So 6 goes 4 times. So I have 36
36
upon 50.
Five
So
into
5
10.
into 10. Now 36 means it will be 5 sevens 35 and 0.2 upon 10. which will be
0.72 ampere.
yeah, so the current in C will be 0.72 ampere. Now I know that if you take 1.8 total minus this also will give you the same thing. Can you see that? But please show this working, take care of that. Understanding?
Yes.
Okay, so this becomes your answer C and this also becomes answer C. Where am I?
Yes, ma'am.
This
Ma'am.
one.
Yes, sir.
What do you understand by kinetic energy learning work? Derive the relationship between. So this is your P square equal to 2mk. You have to derive, learn it up. This is learning work. How can the work done be measured when force applied at an angle in direction of displacement? In the direction of displacement means theta equal to 0. Then W is equal to Fs cos theta, which is Fs cos 0, correct? And
Yes,
then you
ma'am.
know how to proceed. Now pulley system VR is 4. This is the load. Vertical height means DL. This is effort required is this. Can you see whole lot of questions they have asked? They have not asked for this person has done rubbish. Anyway, so what you'll write over here? VR is equal to 4. Load is equal to 175
kgf.
kgf and DL equal to 15 meter. Effort required is
50
50
kgf.
kgf in downward direction. Now downward direction means that MA is equal to VR actually. Alright, but that means there are 4 pulleys only. Understanding?
Yes,
Now
ma'am.
distance moved by the effort, they are asking you DE equal to question mark. So velocity ratio can be linked with displacement of effort upon displacement of load. So 4 is equal to DE upon 15.
15.
So displacement of
60
effort is 15 into 4 means 60
meters.
meters, and you will please write the statement here the way it is here. Okay, that is your answer A. We are doing this fast. For the exam, make sure that you're writing it properly. Work done by the effort. Now, work done by the effort is going to be equal to effort into displacement of effort. Alright, do I know the effort? 50 kgf. So you will have to say that effort is equal to 50 kgf. Therefore, mass of effort. Remember, we don't substitute kgf here. Okay, mass of effort is 50 kg. This is where they are sitting to cut your marks. Understood? Where even if you get your answer same, do you know if you substitute as 50 kgf without showing this step, they can straight give you 0. Did you understand how they are sitting?
Yes, ma'am.
Okay, that's why I told you let's do this paper, because it can have, you know, little simple twist that can give you 0. Understanding?
Yes.
So you will say therefore work done by the effort is going to be 50 kg. No, sorry, mass of the effort, oh dear me, mistake. Here please let us write over there 50 into 10. Let us make it as newtons. Okay, so this will be 500 Newton. You understood? And the displacement of effort is how much? 60 meter. All right. So effort becomes what? Mass is 50. So M into G becomes the force. Understanding? We can't write gravitational unit for the effort. Just remember that. Take care of that.
30,000.
Yes, 30,000 joules.
Joules.
This is your
Joule.
answer B. Yeah.
Ma'am, acceleration due to gravity is also given.
Here it is given 10, no?
Can we substitute?
Yes, ma'am.
Okay, so this is what you will say, since G is equal to 10 meter per second square. We made use of that only. 1 kgf is equal to 10 Newton, no? Because
Yes,
of
ma'am.
this M into G. So if you write this 50 Newton, that is the mass. Mass into G gives you the force in SI unit.
Yes, ma'am. Thank you, ma'am.
Welcome. Now C is MA. Is the load given? Yes. Is the effort given? Yes. How much is the load? Even if it is in kgf, it doesn't matter. This doesn't matter, but for the work done,
50 kg.
But for the work done, you have to make sure that,
5.
yeah, this is how many times it is going. 25 twos and 25 sevens. 3.5. Are you getting 3.5?
Yes, ma'am.
Yes, ma'am.
This is your answer C. Then we come to the efficiency. For the efficiency, it is MA.
Upon VR
Upon
into
VR
100%.
Very good. Everybody is confident about this now.
Yes, ma'am.
3.5 upon 4.
upon 4 into 100.
Huh.
So that will be 7 upon 8 into 100.
7 upon 8 into 100. Okay. I took it this way. Is that okay? 25
Yes.
is 125. Oh, multiplied by 100 nahi kiya maine. Okay. So what did you get here?
Ma'am, we did multiply by 100.
Yes,
Oh yeah,
ma'am.
yeah, I multiplied by 100. See, now I got confused. In between, my link went. Sorry. Yeah, so this is percent. Okay, so 25 5 is 125, carry 12, and 25 3 is 75, 87.5%. Correct? So this is your answer D. How was it? Good, bad, or ugly?
Yes, ma'am. Good, ma'am.
Good, ma'am.
This is the last question. Oh my goodness. How have you made the PDF, mera bacha? Thorium undergoes alpha decay, becomes radium. What is the atomic number? This is not so bad, right?
Yes, ma'am.
Thorium is 23390. It is undergoing alpha decay and it becomes radium plus helium 42 means alpha particle. So 233 minus 4 is how much? 229, and
Upon
90
88.
becomes 88. What is the atomic number? Therefore, atomic number equal to
is
88
88.
and mass
atomic
number.
mass number is 229.
Show the equation and then write. Don't directly write this. It is not your MCQ. Your B part, if the radium undergoes further disintegration, emits 2 beta particles. So we'll have radium 22988 is undergoing 2 beta emissions and represent the reaction in the form of equation. So radium has become, now 2 will get added, so it will become 90. So it will come back to thorium, correct? Because this was 90, this is also 90, understanding? But 229 will be unaffected, plus it will be 2 beta 0 minus 1. If possible, place this in a bracket so that your 2 doesn't look like 20. Understanding? Take care of that. What is the source of energy released during the decay?
Now that should not be beta, that should be electrons, right?
Beta particle is electron only. You can write either this or this. Okay, both are possible. This is also the representation of beta and this also. Okay, both of them are agreeable. What is the source of energy released during this? It will be the nuclear energy. Source of energy,
So
nuclear
yes.
energy, or what else can you write over there? Now they are not talking about this decay or this decay. So what will you write the source?
The excessive number of neutrons in the nucleus.
Yeah, so you will say that
Ma'am, can we get radioisotopes?
radioisotope, you can say unstable nucleus. Okay, unstable nucleus. This is the first part.
Number of neurons.
Neurons? Neurons? Bio? Oh my goodness, bio? Oh. Since number of neutrons is much greater than number of protons. Okay, so due to imbalance. Okay, and then for beta emission, what you'll say, one neutron, which is 1 and 0, splits into a proton, that is 1 1, plus an electron, which is 0 minus 1. Okay, and then you will say this electron from nucleus emitted, but the main source will be unstable nucleus causing imbalance and nuclear energy. I'm just adding this as an afterthought. Nuclear energy is converted into source of energy, so nuclear energy. So you can see about 3 to 4 questions were having slight twist in this. Name the principle of functioning of the transformer, learn it by heart. Step up transformer, I've already told you how to do this. You'll just review this once again. You will draw a rectangle. You will show 2 wires here. This side you will put AC input, and that will be your primary, and this is going to be your AC output, which is going to be secondary. Correct? It is step up, means secondary will have more number of turns, and here you will show less number of turns. Doesn't matter, visibly it should be more here. What will
Excuse
you
me, ma'am.
label this as? Laminated soft iron core.
Excuse me, ma'am. In the primary coil, will we show thickness, more thickness in the?
No thickness is required.
Yes.
Just now you visibly see it is thicker wire, but in the diagram don't show thickness.
Yes, ma'am.
You have to just show the number of turns. Okay, you are saying that should I make this into a slightly thicker one? That is
Yes,
what you are
ma'am.
asking, right?
Yes, ma'am.
Yeah, it could be done. Yes, it could be, but even if you don't, the number of turns is enough to specify that it is a step up transformer. Name it as step up transformer. Understanding?
Yes, ma'am.
Name
Thank you, ma'am.
any one cause of energy loss. There are 4 losses. Please learn them by heart and how can be minimized. So all those are learning works. Of course, the other ones are which coil will be thicker, and that's the time I told you here EMF is less for the given power. Remember that. This is the important phrase. For the given power, if the EMF is less, then the current is more. This is important over here if they ask you for give reason. Understanding. We come to the last page. Oh dear me. Kahan
Next
pe
to
hai?
that one.
Under the right.
This one.
Yes.
Oh my goodness. Okay. Why would he give me like this? Mulga, you're so cute. Huh? You made me dance around for this, no? Okay. Diagram shows the circuit containing coil wound around soft iron. Copy the diagram. Polarity at A and B. Where is A and where is B?
North and south.
Polarity at A and B. So the current goes this way, it is going this way.
Therefore,
North and
Correct?
east and
So
North.
when I'm looking over here, is it going from
90
3 to 12 to 9?
Yes,
Yes,
ma'am.
ma'am.
So it is anti-clockwise. So this becomes north and this becomes south.
South.
Okay. So when they are saying state the polarity, when you write at A and B, will you write this and this? You will get 0.
North and south.
Polarity.
Please write polarity. You have a problem getting that mark.
Sorry. South.
Yeah, you write polarity, just I'm putting ditto marks. Draw the magnetic lines of force inside the
B to A.
inside the coil. So inside the coil, this is north, this is south. So you will have to show like this. Oh, okay. You'll have to go slow and make it neat. All right. This is your north, which is at A, and this is at B, which is south. So you will show first this, all right, then you will show this, just show 3 lines like this, and then you will show this way like a butterfly.
Ma'am, they asked for the inside.
Yeah, I know, but you see this, all right, and this you will show like this. I told you to use the eraser and get this done. Now, remember that all of you know that the magnetic field lines start from,
North to south.
so they will be entering here like so,
South to north.
and inside will be this way, and this way. Make sure that the arrows are visibly seen for each of these lines, okay?
Yes, ma'am.
Yeah, and then you will show this way and you will say mag field inside the coil. Now if you wish to, later on, just to avoid your confusion, you could just clean this if you wish to, but I'm just telling you in case some of you have a little confusion. I have to make sure that all of you get maximum marks. 2 methods to increase the strength of magnetic field.
By increasing the current
number of
and
turns in the
increasing the
coil.
number of turns.
Correct, since directly proportional. Can you change the polarity at A and B? Yes, by reversing
Reversing the current.
the direction of current, not reversing the current.
Just two
Yes, ma'am.
methods. to
Reversing
increase.
the direction of
Two methods bola no? We
This is
said
only
two.
one
No,
increase.
both we said. Both we said. Okay, so that finishes this paper.